All right. So, 3U people, expectation for you guys in terms of grade 11 and doing trig problems would be just ramping up your 3D problems in general. So, instead of maybe a 3D problem involving two triangles, like the classic cliff height question we just did, perhaps one involving three or more triangles. This problem involves three, and it's up to you guys to kind of parse out what am I asked to find here, and then how many steps is it going to be to get there, and what steps, what tools do I need each step of the way. So what we're going to be doing in this lesson is I'm actually just going to let you guys sit with the problem and strategize for a few minutes, and then I will do it with you guys. The actual solving the problem won't take more than a few minutes once we have a strategy. But yeah, that's going to be what we're doing. So I'll let you guys think for a minute or two, come up with a strategy, and then we'll have a talk about the strategy, and then we'll finish it off together. I'll actually pause the video. If you're watching this at home, you can do the same thing. Think of a strategy, and you can unpause when you're ready to go. All right, I'm going to come along for the ride here. When I look at this question and I see we need the height of the antenna, there's actually two triangles here that contain the height of that antenna. There is a right angle triangle that we can form using Sam's house, the antenna, and there's a right angle triangle from Alina's house that involves the antenna as well. One of those triangles has more information than the other, so I can see that I've got the angle of elevation from Alina's house. So I think that that's what I'm going to use for sure. And I'm not your dad. You can do what you want. But I would, for me, I find it helpful to just redraw my triangles, turn everything into a 2D. So here is Alina's house. I'll use A for the top of the antenna. Maybe I'll use T for the bottom of the antenna. Now, ultimately, my goal is to find AT. I was given this angle of elevation of 12 degrees, but that's all I'm given. So you guys have had some time to strategize. Where do we go from here? I can't find that antenna yet. Not enough information. You guys need more time to think about it? Colette, what do you think?
I'd find the adjacent of B using the triangle made between the two houses.
Yes, so I'm gonna just redraw that bottom triangle. Just gonna set it up this way. So we have Sam's house, Elena's house, and the base of the tower forms a right angle triangle as well. No, we know it's right angle triangle, even if the diagram didn't tell us that, because the antenna is north of Sam's house and it is west of Elena's house. This distance is 1,200 meters. This is 50 degrees, and now it's just like the cliff problem from the warm-up. We have two triangles. The third triangle we don't need, it turns out. We've got a shared side, and once we find that shared side, we can find height. So I would argue this is a very similar question to the cliff height, one you could have arguably done from after your grade 10 course. Let's wrap this one up. So we see our strategy. One, we'll find side ET. Two, we'll find the side AT, the antenna height. And this is just, I'm going to use SOHCAHTOA both times. I think we've done this enough at this point that we can kind of proceed through this pretty quickly. So I'm finding the opposite to 50 degrees. So I use the sine ratio. Sine of 50 degrees equals ET over 1,200. 1,200 sine 50, whatever that is. about 919.3. Do you guys get that too? All right. And then to wrap things up, I might add that to my diagram here. And now I can see, okay, that's the adjacent side in that upper triangle with the 12 degrees. I'm looking for the opposite. So now I will use the tangent ratio, the tan of 12 degrees, opposite AT over hypotenuse. Sorry, over opposite, or adjacent, excuse me. It was one of those three, 919.3. 919.3 tan 12. All right, and I got about 195.4. So for the 3U people, expectation is you'll be able to take a 3D problem with more than 2 triangles and create a multi-step strategy using grade 10 trig tools. Nothing in here is like new math from this year, but that's the expectation. All right, anything you guys want to chat about this first one? I might add just to wrap up the problem, this is the antenna height. All right, so in this last one, so this is where the 3U expectation really comes in. In this one, you just have a description of the problem. There's no triangles drawn for you. You guys have to figure out spatially, what am I asked to find here, and how can I set this up in terms of triangles to use my grade 10 skills that we've reviewed together to solve this problem. So here we have a baseball diamond. If you're not familiar, this is just a square. So all of these are right angles at each base. The pitcher pitches the ball. Now this is a top-down view, like we're in the sky in a drone or what have you, just looking straight down. And the ball is popped up directly over home plate. You can think of it as coming out of our screen here. And you guys are asked to find the angle of elevation of the ball when it's at the absolute highest point, 50 meters, as seen by the pitcher. So I'm going to leave this one with you guys for a few minutes to think about what's happening here. Create your own diagrams and strategy to get going. I will not leave you hanging. I will catch up too, but I'm going to let you wrestle with this one. This is the 3U expectation that you can draw it out, even if the math is just grade 10 stuff, but actually representing this problem with a diagram, with some triangles, that's the 3U part of it. I'll pause the video. People at home, you can try to strategize too, and I'll play catch up in a few minutes. All right, I'm gonna put my artiste skills to the test here. What are we trying to find? I'm actually going to draw a little, this is going to be I'll call this a side view of the problem. Side view, I can spell. Here's my pitcher. Let's put a baseball cap on him so we know that he's the pitcher. And here's home plate. And the ball is popped up 15 meters, and we're asked to find the angle of elevation. That's all we're given in that side view of the problem. So we're stuck for now. I'm going to dial in on third base, home plate, and the pitcher. If we could find how far it is from the pitcher to home plate, we'd be good. So I'm going to draw a second triangle here. And this is I'll call it a top-down view. This is a right angle triangle. I'll put a T here for third, an H here for home, and a P for pitcher. But I know from third to home, the question says that's 27.4 meters. And I know due to the geometry of this problem that those two acute angles are both 45 degrees. And now we have the same as the last two problems. It's just here, you guys had to reason it out for yourselves. We have a shared side that we can find the distance from the pitcher to home plate. And this is just right angle triangle stuff. It's first week of grade 10 trig. And then we can find the angle of elevation once we know that pitcher to home plate distance. So it's not the actual trig that's hard. It's the setting the things up. That's the 3U expectation. Yeah, now it's just, you could even use Pythagorean theorem for this one, but let's just use SOHCAHTOA. So 1, let's use the sine of 45. It's the same difference one way or the other. Equals pH over 27.4. Actually, we have the time and the space, so I'll show you guys something. Yeah, the math is straightforward. So the distance from pitcher to home plate, 19.4 meters. I'm going to throw in a big or here as well. If we label that side X in this diagram here, both of those adjacent sides are the same, right? So you could use Pythagorean theorem. Pythagorean theorem says that x squared plus x squared is equal to the hypotenuse squared. That gives you 2x squared equals 27.4. So to get x, you would, squared. To get x, you would take 27.4 squared, divide it by 2, and then square root that. Can you guys humor me and give that a go? Should give us the same thing. 87% confident this will work. Of course it'll work. Nothing bad happens when you try to improvise. Of course it works. 19.4. Very cool. All right, let's wrap up the problem so you guys can get down to business. And so now looking at our side view, we now have this bottom side, 19.4 meters. We found that out. And so now it's just use the tangent ratio, opposite 15 over adjacent 19.4, and we're done. I'll even just quickly do it this way. We're doing inverse tan of whatever 15 meters exactly, over 19.4 will give us our angle of elevation. About 37.7 degrees. That's the max angle of elevation. That's the angle that pitcher has to tilt his head back to see. All right, just one last time. The trig isn't the hard part. You guys did all this stuff in grade 10. But taking a problem where you don't have a diagram that's 3D and strategizing, that is the expectation for you 3U people. All right, so 3U people now, I've got a problem-solving assignment for you guys too. And then it's just assignment, all the live-long day. And I'll come around and touch base with what everybody owes. Because we've done a lot of assignments this year. Believe it or not, unless it's worth marks, some students don't do it.